Hey crew, it's Pitt and I'm back with some more philosophy. Today we're diving back into the works of Mr. Georg Hegel. This is The Science of Logic. We are reading aloud and discussing as we go along the various points that are brought to light by the text. It is not the format for everyone, but people find value in it, so you are more than welcome to tag along as we continue our exploration. Before we begin, however, if you are unfamiliar with me, any of my unconventional beliefs, or if at any point in time I lose you in terminology, there will be several playlists linked in the corner above, in the box down below, along with the original source material, so that you can get a better understanding of who I am and why I say the things that I do. With that being said, we are going to dive in and continue our exploration of the science of logic with Part 2, Chapter 2, Quantum. Quantum, and this is going to be in two parts. Quantum, which in the first instance is quantity with a determinateness or limit in general, and its complete determinateness is number. Second, quantum divides first into extensive quantum, in which limit is the limitation of a determinately existent plurality, and then inasmuch as the existence of this plurality passes over into being for itself, into intensive quantum or degree, this last is for itself but also as indifferent limit, equally outside itself. It thus has its determinateness in another. Third, as this posited contradiction of being determined simply in itself, yet having its determinateness outside itself and pointing outside itself for it, quantum, as thus posited outside itself within itself, passes over into quantitative infinity. A. Number. Quantity is quantum, or has a limit, both as continuous and discrete magnitude. The distinction between these two species has here, in the first instance, no significance, as the sublated being for itself, quantity is already in and for itself, indifferent to its limit. But, equally, the limit, or to be a quantum, is not thereby indifferent to quantity. For quantity contains within itself, as its own moment, the absolute determinateness of the one, and this moment, posited in the continuity or unity of quantity, is its limit, but a limit which remains as the one that quantity in general has become. This one is therefore the principle of quantum, but as the one of quantity. For this reason it is, first, continuous. It is a unity. Second, it is discrete, a plurality, implicit in continuous magnitude or posited in discrete magnitude, of ones that have equality with one another. The said continuity, the same unity. Third, this one is also the negation of the many ones as a simple limit, an excluding of its otherness from itself, a determination of itself in opposition to other quanta. The one is thus alpha, self-referring, beta, enclosing, and delta, other, excluding limit. I'm pretty sure that this is delta. I do not know the Greek alphabet. I probably need to learn that if I'm going to continue doing Hegel, but thus, completely posited in these determinations, quantum is number. The complete positedness lies in the existence of the limit as a plurality, and so in its being distinguished from the unity. Number appears for this reason as a discrete magnitude, but in unity it has continuity as well. It is, therefore, also quantum in its complete determinateness, for in it the limit is the determinate plurality that has the one, the absolutely determined for its principle. Continuity, in which the one is only implicitly present as a sublated moment, posited as unity, is the form of the indeterminateness. Quantum, only as such, is limited in general. Its limit is its abstract, simple determinateness. But as number, this limit is posited as in itself manifold. It contains the many ones that make up its existence, but does not contain them in an indeterminate manner. For the determinateness of the limit falls rather in it. The limit excludes the existence of other ones, that is, of other pluralities, and those which it encloses are a determinate aggregate. They are the amount, or the how many times, with respect to which, taken as discreteness in the way it is in number, the other is the unit, the continuity of the amount. Amount and unit constitute the moments of number. Regarding amount, we must examine yet more closely how the many ones in which it consists are in the limit. It is rightly said of amount that it consists of the many, for the ones are not in it as sublated, but are rather present in it, only posited with the excluding limit, to which they are indifferent. But the limit is not indifferent to them. In the sphere of existence, the limit was at first so placed in relation to existence that the latter was left on this side of its limit, standing there as the affirmative, while the limit, the negation, stood outside on the border of existence. Similarly, with respect to the many ones, their being truncated and the exclusion of the remaining ones appear in them as a determination that falls outside the enclosed ones. But it was found in that sphere of existence that the limit pervades existence, that it extends so far as existence does, and that the something is, for this reason, limited by its very determination, that is finite. Now, in the quantitative sphere, a number, say 100, is so represented that only the 100th unit brings to the many the limit that makes them 100. In one respect, this is correct, but in another respect, none of the ones in the 100 has precedence over any other, for they are only equal. Each is just as much the 100th. They can all thus belong to the limit that makes the number 100. This number cannot dispense with any of them for its determinateness with respect to the 100th. Therefore, the rest do not constitute a determinate existence, which is in any way different from whether inside or outside the limit. Consequently, the number is not a plurality over against the limiting one that encloses it, but itself constitutes the limitation, which is a determinate quantum. The many constitute a number, A1, A2, A10, A100, etc. So what is being said here is that if you have 100 of an item, right, whatever it is, we'll use toothpicks. It doesn't matter in which order that you count the toothpicks, every single one of the toothpicks is intrinsic to it actually being 100. And if you take any one in particular away, it is no longer 100. It is something else, 99. It doesn't matter which order you count it in. The one that you count as 1, you can count as 100. Either way, it is part of the determinateness that these are delimited into 100 of this individual thing. Back to the text. Now, the limiting one is a discriminating determinateness, the distinguishing of a number from other numbers. But this distinguishing does not become a qualitative determinateness. It remains rather quantitative, falling only within the compass of comparing, of external reflection. As one, the number remains turned back onto itself and indifferent to others. This indifference of numbers to others is its essential determination. It constitutes its being determined in itself, but at the same time also its own exteriority. Number is thus a numerical one that is absolutely determined, but which has at the same time the form of simple immediacy, and to which, therefore, the connecting reference to an other remains completely external. Further, as numerical, the one possesses the determinateness, such as consist in the reference to other, as a moment in it, in its distinction of unit and amount is itself the plurality of the ones. That is, this absolute exteriority is, in the one itself, this intrinsic contradiction of number, or of quantum in general, is the quality of quantum, and the contradiction will develop in the further determinations of this quality. Remark 1. Spatial magnitude and numerical magnitude are usually regarded as two species, in the sense that the former is, as such, just as much a determinate magnitude as the latter. Their only difference, it is said, consists in the diverse determinations of continuity and discreteness. But, as quantum, they stand on the same level. In spatial magnitude, geometry has, in general, continuous magnitude for its subject matter, while the subject matter of arithmetic is discrete magnitude. However, with this disparity of subject matters, they also have an inequality in the manner and completeness of delimitation or determinateness. Spatial magnitude has only delimitation in general. When considered as an absolutely determined quantum, it requires number. Geometry as such does not measure spatial figures, is not an art of measuring, but only compares them. Even in its definitions, the determinations are sometimes drawn from the equality of the sides and angles, or from the equality of distance. The circle, for instance, does not require number, for it is based solely on the equality of the distance of all of its possible points from a center point. These determinations, based on equality or inequality, are properly geometrical. But they are not sufficient, and for other figures, such as the triangle or the quadrangle, number is required. And number contains self-determinateness in its principle, the one, without the aid of an other, and thus not through comparison. To be sure, in the point spatial magnitude possesses the determinateness that corresponds to the one, but this point, in being externalized, becomes an other, becomes a line. Because it is essentially a one, which is only spatial, in connection, it becomes a continuity in which puncticity, let's see if that footnote is actually something. It's the root word. Puncticity, self-determinateness, the one, is sublated. To the extent that in self-externality the self-determinateness is to be retained, the line must be represented as an aggregate of ones, and the limit must receive the determination of many ones. That is, the magnitude of the line, and of the other spatial determinations as well, must be taken as number. Arithmetic treats number and its figures, or more accurately, it does not treat them, but rather operates with them. For number is indifferent, inert determinateness, such as must therefore be activated and brought into connection from outside. The modes of connection are the species of calculation. These are performed in arithmetic one after another, and it is evident that each depend on the other, even though the thread guiding their progression is not brought out in arithmetic. However, the systemization to which textbooks are rightly entitled can easily be drawn from the conceptual determination of number itself. These guiding determinations will be briefly noted here. Because of its principle, which is the one, number is, in all instances, an external aggregate, simply an analytical figure without any inner connectedness. And because it is thus produced only externally, all calculation is a generation of numbers, or a counting, or, more precisely, a summing up. Any diversity in this external production that always simply repeats itself can rest only on a difference in the numbers that are to be summed up. but any such difference must be imported from elsewhere as an external determination. The qualitative difference that constitutes the determinateness of number is, as we have seen, that of unit and amount. Every conceptual determinateness possible in the operations of calculations is reduced, therefore, to these two. The difference, however, which accrues to numbers as quanta is external identity and external distinction, equality and inequality. And these are moments of reflection which we shall have to treat among the determinations of essence under the heading of difference. We must also mention in advance that numbers can, in general, be generated in two ways, either by combining or by separating combinations already made, and since both operations are performed with a species of counting which is determined in one and the same way, to the combining of numbers, an operation can be called positive. There corresponds the separating of them, which can be called a negative operation. But the determination of the species of calculation itself is independent of this opposition. 1. After these preliminaries, we proceed with the details of the modes of calculation. A first generation of number is the combining of the many as such, each of which is posited as only a one numbering. Since the ones are external to each other, they are pictured in a sense image, and the operation by which number is generated is a reckoning on the fingertips, dots, etc. What 4 is, or 5, can only be indicated. Since the limit is external, the breaking off point, how much is to be taken is something accidental, arbitrary. The difference of amount and unit that emerges in the progression of each species of calculation is the basis of a system of numbers, dyadic, decadic, and so forth. Any such system rests totally on arbitrariness, on which amount is taken to count as the constant unit. The numbers produced by counting are counted in turn, and in thus being immediately posited, they are still determined without any reference connecting them to each other, indifferent to equality or inequality, their relative magnitude accidental, and hence unequal in general. This is addition. We see that 7 and 5 make 12 by adding 5 more ones to the 7 on our fingertips or in some other way, and the result is then imprinted in memory by rote, for there is no external constraint to the procedure. Similarly, we know that 7 times 5 is 35 by counting off on fingertips, etc., by adding one 7 to another 7 and repeating the operation 5 times, and the result is equally memorized. The labor of this counting, the ascertaining of the sums of the products, is relieved by ready-made addition or multiplication tables, which one has only to learn by heart. Kant regards the proposition 7 plus 5 equals 12 as synthetic in the introduction to the Critique of Pure Reason. One should, he says, indeed think at the start, of course, that it is an analytical proposition, one that derives from the concept of the sum of 7 and 5 according to the principle of contradiction. The concept of the sum has no other meaning than this, that these two numbers are requested to be combined, and indeed, because they are numbers, externally combined. That is, in a way that is conceptually unconstrained or mechanically. That from 7 one should go on counting until the ones to be added, their amount being fixed at 5, have been exhausted, and the result carries the otherwise familiar name of 12. However, Kant continues, if one considers the matter more closely, one finds that the concept of the sum of 7 and 5 contained nothing more than the union of the two numbers into a single one. through which it is not at all thought, which is the single number is that comprehends the two of them. However much I might go on analyzing my concept of such a possible sum, I shall still not run across the number 12. Of course, the transition from the set task to the results has nothing to do with thinking the sum or analyzing the concept. And Kant adds, one must go outside these concepts and enlist the aid of intuition, of five fingers, etc., thus adding to the concept of 7 the units of 5 which is given in intuition. Yes, 5 is given in intuition. That is, it is an entity put together in an entirely external fashion by the arbitrary repetition of the thought 1. But 7 is equally not a concept. There are no concepts here to go outside of. The sum of 5 and 7 is the conceptually unconstrained joining of the two numbers. One can call such a mechanical process of counting from 7 onwards until the 5s have been exhausted, and adding a synthesizing, exactly like the counting from 1 onwards to 5, a synthesizing. However, which is wholly analytical in nature, for the combination is only an artifact in which there is nothing, or to which nothing is added, which was not previously there in external fashion. The postulate that 5 be added to 7 stands to the postulate of counting in general, in the same way as the postulate that a straight line be extended stands for the postulate of drawing a line. Just as vacuous as the expression to synthesize is to say that this synthesizing takes place a priori, counting is, of course, not a determination of the senses, which, according to Kant's definition of intuition, is all that is left over for the a posteriori, and it certainly is an affair conducted on the basis of abstract intuition. That is, one which is determined by the category of the one, where abstraction is made from all other sense determinations, and no less so also from concepts. The a priori is something all too vague. Feeling, determined as drive, sense, and so on, has in it the moment of the a priori, just as much as space and time, in the concrete shapes of temporal and spatial existence, is determined a posteriori. It can be added in this connection that Kant's claim about the synthetic character of the principles of pure geometry is equally without solid ground. He grants that several are really analytical, while giving as example, in support of his claim, that they are synthetic only the principle that the straight line is the shortest between 2 points. For my concept of straight contains nothing of magnitude, but only a quality. The concept of shortest is thus entirely added to it, and cannot be analytically derived from the concept of the straight line. Intuition must therefore be enlisted as an aid, and only by means of it is the synthesis possible. Here, too, however, we are not dealing with the concept of straight in general, but with the straight line, and this latter is already something spatial, intuited. The determination of the straight line, or, if one prefers its concept, is none other than that it is an absolutely simple line. That is, that in coming outside of itself, the so-called movement of the point, it refers simply to itself. That in being extended, no diversity of determination, no reference to some other point or line outside it, is posited. It is simple, absolutely, internally determined direction. This simplicity is indeed its quality, and if the straight line seems difficult to define analytically, this is so precisely because of its simplicity and self-referential character, whereas reflection looks for determination first and foremost in a plurality. in a determining through something else. But there is absolutely nothing inherently difficult in grasping this determination of simple internal extension, this absence of determination by another. Euclid's definition contains nothing else than this simplicity. But now, the transition of this quality to the quantitative determination, the shortest, that allegedly constitutes the synthetic factor, is in fact entirely analytical. As spatial, the line is quantity in general. When said of the quantum, the simplest means the least, and when said of line, it means the shortest. Geometry can accept these determinations as a corollary to the definition, but Archimedes, in his books on the sphere and the cylinder, see Halber's Translations, page 4, took the most advisable course by introducing this determination of the straight line as an axiom in just as correct a sense as Euclid included the determination concerning parallel lines among the axioms. For the development of this determination into a definition would have also required determinations that do not belong to spatiality immediately, but are rather of a more abstract qualitative character, like the simplicity and sameness of direction just mentioned. These ancients gave even to their sciences a plastic character, rigorously confining their exposition to the distinctive properties of their material, and thus excluding from it anything heterogeneous to it. Kant's concept of synthetic a priori judgments, the concepts of terms that are distinct and yet equally inseparable, of an identity which is within it an inseparable difference, belongs to what is great and imperishable in his philosophy. To be sure, this concept is also equally present in intuition, for it is the concept as such, and everything is the concept implicitly. But the determinations selected in those examples do not exhibit it. Number is an identity, and counting the production of it, which is absolutely external, a merely superficial synthesis, a unity of ones that are rather posited as not inherently identical with each other, but external, each separate for itself. The determination of the straight line of being the shortest between 2 points is based on a moment of abstract, internally undifferentiated identity. I return from this digression to addition itself, the corresponding negative species of calculation, subtraction, is the equally entirely analytical separation into numbers, which, just as in addition, are determined relatively to one another only as unequal in general. 2. The next determination is the equality of the numbers that are to be counted. Because of this equality, the numbers constitute one unity, and there, thus, accrues to number the distinction of unit and amount. Multiplication is the task of counting up an amount of units that are themselves each an amount. It is therefore immaterial which of the two numbers is given as unit and which as amount, whether one says 4 times 3, where 4 is the amount and 3 the unit, or, conversely, 3 times 4. We have already indicated above that the original finding of the product is done by simple counting, that is, by counting off on fingertips, etc. The subsequent ability to come up with the product straight away rests on the collection of such products, on the multiplication table, and on learning it by heart. Division is the negative species of calculation with this same determination of difference. It is equally immaterial which of the two factors, the divisor or the quotient, is taken as unit or as amount. The divisor is determined as unit and the quotient as amount whenever the stated task of the division is to see how many times the amount, a number, the unit, is contained in a given number. Conversely, the divisor is taken as the amount and the quotient a unit whenever the stated intent is to partition a number into a given amount of equal parts and to find the magnitude of the part of the unit. 3. The two numbers that are determined with respect to each other as unit and amount still are, as numbers, immediate to each other and are therefore unequal in general. The further equality is that unit and amount themselves, and with this, the progression of the equality of the determinations inherent in the determination of number is completed. On the basis of this complete equality, counting is the raising to a power. The negative counterpart of this calculation is the extraction of a root. And this raising to a power constitutes, in the first instance, as a squaring of a number, the complete inherent determinateness of counting where 1. The many numbers are to be added to the same, and 2. Their plurality or amount is itself the same as the number which is posited a plurality of times, or the unit. There otherwise are no determinations in the concept of number that could provide a difference, nor is there a place for any further equalizing of the difference inherent in number. To raise a number to powers higher than the square is a formal continuation of the squaring, both in the case of even exponents, where it is only a repetition of the squaring, and in the case of the uneven, where inequality resurfaces, in the simplest case of a cube, for instance. Despite the formal equality of the new factor with both the amount and the unit, the new factor is a unit unequal as against the amount. The square, 3, against 3 times 3. And even more so in the case of the cube of 4, where the times by which the number, which is the unit, is to be multiplied by itself, 3, differs from this very number. Here we have in themselves the determinations, amount, and unit, which, as the essential difference of the concept, are to be equalized for the complete return to itself of the self-externalized concept. The foregoing exposition also contains the reasons why the solution of higher equations must lie in their reduction to quadratics, and also why equations with uneven exponents can only be formally determined, and exactly when the roots are rational, these cannot be established than by means of some imaginary expression. That is, by the opposite of what the roots are and express. It is clear from what has been said that the arithmetical square alone contains a determinateness which is inherent to it and absolute. For this reason, the equations of higher formal powers must be reduced back to it. Just as in geometry, the right-angled triangle contains a determinateness absolutely inherent in it, which is expounded in the Pythagorean theorem. And for this reason, all other geometrical figures must also be reduced to it for their determination. An instruction that proceeds methodically based on logically disciplined judgment treats powers before it treats proportions. These last do follow upon the difference of unit and amount that constitutes the determination of the second species of calculation, but they proceed from the one of the immediate quantum, in which unit and amount are only moments. The further determination of the one quantum still remains external to quantum itself. In ratio, number is no longer an immediate quantum. It then has a determinateness as a mediation. This quantitative relation, the ratio, will be considered later on. The step-by-step determination of the species of calculation that we have just given cannot be said to be a philosophical treatment of them, not an exposition of their inner meaning, as it were, for it is not, in fact, an imminent development of the concept. However, philosophy must know how to distinguish what is by nature a self-external material. It must know that, as far as this material goes, the concept can make its way forward only externally, and its moments only can be only in the form peculiar to their externality, as here equality and inequality. To distinguish the spheres to which a specific form of the concept belongs, that is, in which the concept is present in concrete existence, is an essential requirement when philosophizing about real objects. This is to prevent ideas from interfering with the peculiar nature of externality and accidentality, and the ideas themselves, because of the disproportionateness of the material, from being distorted and reduced to a formalism. Here, however, the externality in which the moments of the concepts appear in this external material, number, is the appropriate form, since these moments display the subject matter in the conceptual form of the understanding which is appropriate to it, and also since they contain no demand for speculative thought and therefore have the semblance of being easy. They deserve to be employed in the elementary textbooks. Remark 2. It is well known that Pythagoras depicted rational relations, or philosophemata, in numbers. And in more recent times, numbers and forms of their relations, such as powers, etc., have again been used in philosophy for the purpose of regulating thoughts or expressing them. For pedagogical purposes, number is regarded as the most suitable subject matter of inner intuition, and the operations of calculating numerical relations are taken as the activity of spirit, in which the latter visualizes its most characteristic relations, and, in general, the fundamental relations of essence. How far number can live up to this high esteem of its worth can be seen from the concept of it just given. We saw that number is the absolute determinateness of quantity, and that its element is the difference which has become indifferent. Implicit determinateness, which is posited at the same time as only entirely external. Arithmetic is an analytical science, since all the combinations and all the differences that occur in the subject matter do not originate in it, but are imported into it entirely from outside. Arithmetic does not have any object that might harbor within it such inner relations as would be concealed to knowledge at first, because they are not given in its immediate representation, but are only elicited through the effort of cognition. Not only does arithmetic not contain the concept and the intellectual task of conceptualization that goes with it, it is the very opposite of the concept. Here, because of the indifference of the combined to the combining, a combining that lacks necessity, thought finds itself engaged in an activity which is at the same time the utter externalization of itself, a tour de force, in which it moves in an element void of thought, drawing relations where there is no capacity for necessary relations. The subject matter is the abstract thought of externality itself. As this thought of externality, number is at the same time the abstraction from the manifold of the senses. It has retained nothing of the senses except the abstract determination of externality itself, and in it the senses are thus brought closest to thought. Number is the pure thought of thought's own externalization. It may, therefore, occur to spirit as it rises above the world of the senses and recognizes its own essence, as it seeks an element for the pure representation of it, for the expression of its essence, before it grasps thought itself as this element and wins the purely spiritual expression for its exposition. It may occur to spirit to choose number, this inner abstract externality, as the element. For this reason, we see number early in the history of science being used for the expression of philosophomata. Number constitutes the final stage in an imperfect grasp of the universal, still encumbered by the senses. The ancients were clearly aware that number stands midway between these senses and thought. Aristotle cites Plato as saying that the mathematical determinations of things, being outside both the senses and the ideas, stands in between them. They are distinguished from the senses by being invisible, eternal, and unmoved. From the ideas, on the other hand, by being a many and a like, whereas the idea is absolutely self-identical and a one in itself. A more thorough and more profound reflection on the subject by Moderatus of Gades is cited in Malachi Vita Pythagorae. That the Pythagoreans hit on numbers he attributes to the fact that they were still incapable of grasping fundamental ideas and first principles clearly in reason, for these principles are difficult to think and difficult to give expression to. Numbers serve well in instruction as signposts. In this, among other things, the Pythagoreans have imitated the geometers, who, unable to express what is corporeal in thoughts, use figures and say, "This is a triangle," by which they do not mean, however, that the visible figure is to be taken as the triangle, but that it only represents the thought of the triangle. In this way did the Pythagoreans express the thought of unity, of self-sameness and equality, and the ground of congruence, of combination and the sustaining of everything, of the self-identical, as a one, and so forth. It is superfluous to remark that the Pythagoreans did make the step from numerical to thought expression, to the explicit categories of the like and unlike, of limit and infinity, and even with respect to their numerical expressions, it is reported in the remark on page 3.1.5 from A Life of Pythagoras by Photius, that they distinguished between the monos and the one, taking the monos as thought and the one as the number, and they likewise took the two as the arithmetical indeterminate of the dais. For this is what it would surely have to mean here, as the thought of the indeterminate. These ancients, at the outset, saw quite rightly the inadequacy of numerical forms for thought determinations, and they just as rightly went on to demand for thought, instead of that first expedient, the expression appropriate to it. This is how much further ahead they had come in their reflection than those who nowadays consider it praiseworthy, indeed profoundly sound, to revert to the helplessness of childhood, and in the place of thought determinations, to reinstate numbers themselves, and numerical determinations like powers, followed by the infinitely great, the infinitely small, one divided by the infinite, and other such determinations, which are themselves often a perverse mathematical formalism. In connection with the just cited claim, the number stands between the senses and thought, since it has in common with the former that it is in itself the self-externality of the many. It must now be noted that this many is itself the sensuous as taken up in thought, the category of the internally self-external that defines the sensuous. When more advanced thoughts, thoughts that are concrete and truly thoughts, when what is alive and active in a high degree and requires context in order to be comprehended, when these are transposed into this element of externality, they turn into dead, motionless determinations. The richer indeterminateness and hence in connections thoughts, the richer the indeterminateness and hence in connections thoughts become, the more confused and also the more arbitrary and meaningless becomes their representation in such forms as numbers. The 1, the 2, the 3, the 4, henus or monus, dies, trias, tetractus, still fall in the general vicinity of totally simple and abstract concepts, but when numbers are extended to concrete relations, it is in vain to try to maintain any approximation to the concept. But that the determinations for the movement of the concept by which alone the latter is concept would be designated as 1, 2, 3, 4 is the hardest to expect of thought. For thought then moves in an element which is opposite to it, where there are no connections. Its labor is one of derangement. The difficulty of this expectation, to understand that, for instance, 1 is 3 and 3 is 1, is due to the fact that 1 is devoid of connections. It does not exhibit in it the determination by virtue of which it passes over into its opposite, but is rather the very exclusion and rejection of such a connection. Conversely, the understanding makes use of this difficulty to debunk speculative truth, as it does, for instance, when the truth laid down in the doctrine called the Trinity. It counts the determinations of that constitute one unity in order to expose them as plain nonsense, which is to say, the understanding itself commits the nonsense of making that which is pure reference into something devoid of all relation. By the name Trinity, triunity, nobody expected that 1 and number would be considered by the understanding as the essential determinateness of the content. This name expresses contempt for the understanding, which has, nevertheless, held fast to its conceit of clinging to the 1 and number as such, standing by it against reason. To take numbers and geometrical figures, as has often been done, as merely symbols, the circle, for instance, of eternity, the triangle of the Trinity, is on the one hand harmless enough, but on the other hand, it is foolish to believe that more is thereby expressed than can be comprehended and expressed by thought. As profound a wisdom, as profound a meaning may lie in such symbols, and also in those that fantasy has created in the mythologies of the peoples and poetry in general, compared with which the dull figures of geometry leave a lot to be desired anyway, it is still up to thinking alone to extract this wisdom and bring it to light, a wisdom that is only implicit in them, and not only in symbols, but in nature and in spirit. In symbols, the truth is still clouded and veiled by the sensuous, and only in the form of thought does it become totally manifest to consciousness. The meaning is only the thought itself. Essentially, however, the perversity of enlisting mathematical categories for injecting some determination into the method and the content of philosophical science shows in the fact that, inasmuch as mathematical formulas signify thoughts and conceptual distinctions, this meaning must, rather, first be indicated, determined, and justified in philosophy. In its concrete sciences, philosophy must take its logical element from logic, not from mathematics. It can only be an expedient of philosophical incapacity to resort for the logical element of philosophy to the shapes which it assumes in other sciences. many of which are only adumbrations of this element and others, even perversions of it. Besides, the mere application of such borrowed formulas is an external operation. The application itself must be preceded by the awareness of both their value and their meaning, and only the consideration of thought, not any authority drawn from mathematics, yields this awareness. Logic itself is this awareness regarding such formulas. It strips them from their particular form, rendering it superfluous and useless. It rectifies them and alone procures for them their justification, their sense, and value. As for any supposed use that numbering calculation might have for basic pedagogical formation, it follows by itself from what has been said so far. Number is not an object of the senses, and to be occupied with numbers and numerical combinations is not the business of the senses. Such an occupation, therefore, encourages spirit to engage in reflection and the inner work of abstraction, and this is of great, though one-sided importance. For on the other hand, since the basis of numbers is only an external, thoughtless difference, the occupation proceeds without a concept, mechanically. The effort consists above all in holding on to something non-conceptual and in combining it non-conceptually. The content is the empty one. So the solid nourishment of moral and spiritual life in its individual shapes, on which, as the noblest ailment, education should nurture the young spirit, is to be ousted by this one, which is void of content. When those exercises are made the main subject and the main occupation, the only possible outcome must be to dull the spirit and to empty it of both form and content. Since calculation is so much of an external and therefore mechanical business, it has been possible to manufacture machines that perform arithmetical operations with complete accuracy. It is enough to know this fact alone about the nature of calculation to decide on the merit of the idea of making it the main instrument of the education of spirit, of stretching spirit on the rack in order to perfect it as a machine. And that is going to bring us to the end of this particular section, right? We are going to pick up on the other side because I try to keep them around an hour, even though some are not able to do so. Right? This has a good stopping point, so we're going to take it. Hopefully I brought a little bit of enlightenment and not too much confusion to a somewhat difficult topic. I have some unconventional beliefs. I have a tendency to step on toes when I relay those. It is not intentional, and I do not apologize for it. I didn't have a whole lot to add to this. This is basic concepts to me. Right? It does not even really need a whole lot of explanation, and so I'm not going to just talk to hear myself talk. Numbers are conceptual. They are not reality. That is true. The grouping together of numbers is arbitrary in relation to your observation of them. So it is an external thing being placed upon them. These values do have reasons, but not always well-defined ones. Sometimes it is an arbitrary division. The use of the conceptualization of numbers for spiritual things does make sense, even outside of the delineations necessarily explained here, right? If you are going to think of the Trinity, then you have to have the concept of three. That doesn't mean that the three is actually broken into anything. There is only one existence, and we all share it through the various differentiations that we each experience, right? If you'd like more on that, I got a playlist called the Infinite Integrations Playlist, and I got another one called Esoterica. Both of those we explore those concepts in much more detail. If you like what I'm doing over here, let me know down below. Give me a like, a share, a follow. Throw me a comment if you agree or disagree with anything that was stated. Drop it in the box down below, and if it remains respectful, it will get to remain up. If there's another work you would like to see me read aloud or discuss, drop that in the comments as well. And if you really like what I'm doing, hit me with that super thanks or even a membership. the bills don't pay themselves. To the crew, thanks for hanging out. I appreciate every single minute that you are here with me, and I am praying for you every single day. Until next time, I love you. God loves you. You are perfect, whole, and complete just the way that you are. And this has been Pitt's Take. Peace.